Hi guys, and welcome back to another chemistry video. Just a little note before we get started, this video is going to be divided into two parts. So this first part is going to be about chemical equations and balancing and reactivity patterns, alright? So we're going to get into those things, and by the end of the video, you'll be like this duck, and you are not going to be like this duck, okay? So let's get into these first two things. So let's talk about chemical equations. This is the very basic example of a chemical equation. It's not balanced yet, but we'll get to that. And basically, we have our reactants on this side, and that will yield, a reaction will happen that will yield a product. And basically, when looking at equations, a very important thing to understand is the law of conservation of mass. And I'm sure you've heard it before. It's the rule that no matter is ever created or destroyed in a reaction. It's always just going to be kind of rearranged. That's how I think of it. So in a reaction, like bonds will be broken, bonds will be formed, and just to rearrange the already existing elements here into something new. So let's talk about some balancing tips. Let's try to balance this equation. We're always going to want to double check our answers. We're going to be careful with diatomic elements, and we're always going to try to get even numbers, especially when working with diatomic elements. So this one, we have kind of unlucky. We have two diatomic elements, but it's okay. So what we're going to realize is that what is wrong with this equation? The H2 looks fine, but the oxygen is off. There's two oxygen on this side, but there's only one oxygen on this side. So immediately you're just going to be thinking, oh, I'm going to add a 2 here. And that balances the oxygen. And we don't have to worry about the H2 because you can just add a 2 on this side and then immediately it's balanced. Sometimes it's just as simple as that. So just make sure you're keeping track of that, and we can double check it as well. There's 4 hydrogens on this side and 2 oxygens on that side. You know it's going to be correct. Just be very careful when balancing. And let's do some other examples other than this equation. These don't have states of matters, but like on a test, if you are asked to know state of matters, then it's very important that you know these. But sometimes it'll just be like, oh, you don't have to mark the states of matter. Sometimes they're just going to test you on your ability to balance. So let's try this example. This one, very interesting. So in this one especially, we're going to follow the rule that we're trying to get even numbers here. Okay, so let's figure this out. There's a 3 here. I don't like this 3. We're going to try to make it a nicer number. I'm going to put a 2 here just so we have a nice number of 6 nitrogen on this side. Another way you can get that is that you see there's an N3 here and an N2 here. The least common multiple of those two is going to be 6. So you're going to want to get 6 nitrogen on either side for the equation to be balanced. So we can just put a 3 here. Our nitrogens are taken care of, and all we need to worry about now is our sodium, and we can just add a 2 there. Now a little trickier one is this one. It's a word equation. So you not only have to balance everything correctly after you write the equation, you have to write the equation correctly in the first place too. And you have to make sure in each compound the charges are balanced, you're not messing anything up, and stuff like that. So aluminum sulfate, we know aluminum has a charge of 3 because it's in this group right here, group 3A, and that has charges of 3. And sulfate ion has a -2 charge, okay? So to balance it, we're gonna have to add a 2 here, so it has a +6 charge, and our sulfate ion here, we need 3 of them, so it'll have a +6 here, -6 here. So that is balanced. So we're going to go step by step, making sure everything here is balanced, okay? And now we have barium. Barium, where is that? Barium is in group 2. It's going to have a +2 charge. And chlorine has a -1 charge, so we need 2 of that to balance it. Just be very careful. I want you to be checking every single step as you do this here, okay? And then aluminum chloride, we already know aluminum has a charge of 3, and so consequently there has to be 3 chlorides, so it's +3 -3. And barium sulfate, barium +2 and sulfate is -2, so you don't have to do anything there. So we have our equation here, but it's not balanced. Yeah, you guessed it. But it's fine because we can do it, all right? So I just like to go think about the easiest elements to start with. I think we can just start off with aluminum. Don't be afraid if you think you don't know what you're doing. Oftentimes, if you just try things, it'll work out. So don't panic when you see something like this, okay? So we took care of our aluminum. There's a 2 there. But now we have to take care of our chlorine. So there's 6 chlorine now, and so we need to make sure there's 6 chlorine on this side. So we'll put a 3 there. Now our chlorine is balanced. We have to worry about barium. And there's 3 barium, so we have to add 3 here. But we have to check our sulfate now. Oh, would you look at that? It just works out. Isn't that awesome? So yeah, balancing equations, you just have to kind of go with it and it'll work out. So don't be scared of them. So before we move on from chemical equations, I want to talk about some simple reactivity patterns. All you need to know basically at this point is that francium is the most reactive metal. So basically the model of francium looks like this. It has a ton of levels. It's not drawn to scale. Well, hydrogen is just like this, okay? It's just like one. There's a nucleus in the middle and there's an electron there. Let's compare these two, all right? This entire row of metals is reactive. So first of all, this group of metals has only 1 electron on the outer shell. This makes it super easy for electrons to transfer during a reaction. So it's super reactive because the electron will just go flying somewhere else, all right? But in francium, it's more reactive because this electron is so far away from the nucleus here. Unlike hydrogen, it's still pretty reactive, but this is much less affected by the pull, so it'll go flying even further, So it's super reactive. And the same thing is true with fluorine, except it's super easy to gain an electron because fluorine has the nucleus too, but it has 7 electrons, 1, 2, 3, 4, 5, 6, 7 out here. And it needs 1 more electron to become stable. Like another element will be here. And it's gonna need the electron from it, all right? And it's super easy for that electron to get attracted there because the nucleus is super close and it'll be pulling it with a lot of force, and that's what makes it reactive. So that's how you can remember that these 2 elements are super reactive. I just wrote that's the most reactive nonmetal, and you can just remember it as bottom left and top right. I just wanted to quickly explain how that works. Okay, so we talked about some chemical equations and balancing. We did some examples, and I quickly explained some simple reactivity patterns. In the next video, we'll cover a lot more mathematical stuff with formula weights, percent composition, everything about the mole, and empirical and molecular calculations. So when the video gets out, you can go to it if you're wondering about how you do these things.